look at the next step in roughing in the cavity. So we did all this roughing with flat end mills. We did a big 20 millimeter to mow it out of there quickly, and then we stepped down to a 10 millimeter, and now we're at a 5 millimeter ball end mill, and we're going to. Okay, so I copied this parallel path, and I was like, oh, I don't need to cut outside these boundaries. We just need to stay on the inside. So I copied it and I pasted it, and then I changed the direction to go this way, and I'll show you how to do that. But one of the things I did was I drew a boundary to keep it all within a sketch. So you can go out of manufacturing, you go back into design, and you design a sketch in there. But let's simulate this thing, and I just want to show you. Actually, let's look at the cutter path first. So we're going to right click and we're going to go edit up at the top, and then we're going to look at this cutter path right here. And I leave all the speeds and the cutter the same, and the geometry, I select this chain boundary right here, this sketch, and that's what keeps it all within the boundary here. And then I kept going over, and I changed the step down to 1/1000ths, and then the step over to 1/1000 because it was at 5/1000ths that created that real roughing pass. And you'll see it before we run this simulation. And then we want to go and we want to change the stock to leave. We're going to clean it up a little bit closer, and it's going to get in there deeper. And I put a quarter of a millimeter, 0.25 mm, as the stock to leave. And those are the things that I changed, and the direction. The past direction is like I click on this long edge and it goes, oh, I'm going this way versus that way. So you can change the past direction here. So I'm going to hit OK. And then I'm just going to right click and I'm going to say simulate. And we're going to look at what we had before. So we had all this rough stuff that it was kind of stepping over, and it was really rough. These are some of the end cutters of the flat end mill, but this is the ball end mill, stepping over big 5 millimeter steps to rough it out. So now we're going to get tighter, and we're going to come in and we're going to really get going. So I'm going to hit play and watch this routine run. All right, here we go. So now it's starting to clean everything up, and we're going in there, and now it's going to go down and it's going to get closer to the surface, and it's really cleaning things up. So it's just a 1 millimeter step over. So we get rid of all those scallops that we were seeing before. So these scallops are starting to go away, and it's starting to become a little bit smoother surface. So that is, we're still leaving a quarter of a millimeter, 0.25 mm, on the surface to do a final cleanup. So once this is done, I want to go in and find all the flat surfaces and machine just the flat surfaces with a small end mill. And we can take those to nominal, where we want it to be flat. And so here's the simulation. It's almost done. It's going all the way across. And this time to machine was only 9 hours to do that. So we're going a lot faster. And so now that's done. So let's exit this simulation. And what I want to do is I want to go to back to 2D machining. Oh, I'm sorry, flat in 3D. It's going to look for all the flats in a three-dimensional format. So I click flat, and then I have to change my tool from a ball end mill to a flat tool. So I'm going to go over here to the cloud tools here. Whoops, cloud. And I've got a 10 millimeter flat, and then I've got some smaller flats. I've got like a 2 millimeter flat end mill, but I'm gonna, oh, and then there's a 4 millimeter flat end mill. So let's use this, let's do the 10 millimeter flat end mill first. And we're gonna select this. No, oh, that's a ball end mill, I'm sorry. Select it again, and we're going to go to cloud tools, and we're going to grab the 10 millimeter flat end mill, and we're going to go right to nominal. We're going to select this, and then we're going to select the geometry, which is all this, bounding box. Whoops. There we go. It's going to all be in there. And we're going to machine this thing to, we're not going to leave any stock. We're just going to go right to nominal. So watch what happens. I'm going to hit OK. All right. And so here we go. It's coming in, and it's going to work around everything and try to get in there and hit everything to the final number on that. Okay, now we're going to simulate that. And watch what it does. So we're going to hit play. So we still have a lot, like the sculpting that didn't get in there. Watch what happens. We're going to hit play, and it just hits all these surfaces. So now it's cleaned them all up, right down to where the mold shuts off. Okay, but we still have some features in here that couldn't get into. So I'm gonna exit out of this, and I'm just gonna copy this routine. I'm gonna right click and I'm gonna say copy, and then I'm gonna click on the setup and I'm gonna go paste, right click, paste. And then I'm gonna right click on that copy and I'm gonna edit it and change the tool. I'm gonna go edit, and I'm going to change the tool, and I'm going to select the smaller, that little 4mm tool. But I'm going to also bring in the boundaries where we were cutting that. So there's the 10mm flat end mill, and I'm going to come down to a 4mm. No, that's a ball end mill. I'm sorry, a 2mm flat end mill, and I'm going to select that, and then I'm going to change the geometry, and I'm going to get rid of the outside. I'm going to use this to keep it within those boundaries. And I'm going to say, okay, machine everything to nominal. And so now it's going to go in and it's going to generate a tool path, and it's going to get way down in there, and it's going to get all the little flats like down in here, and it's going to clean up all these little things like here and that the bigger cutter couldn't get into. Down in here probably. So then we're going to simulate this. So this simulation will be interesting, and let's see what happens. And then we simulate, right click and simulate, and you can see all the little cutter paths. So here we are after the one main thing got in there, and it couldn't get into these locations here because it's flat along here. And so let's see if it gets in there, and it's got a lot of areas that it needs to tighten up. So we're going to go hit and play, and here it goes. And look, it got in there, it cleaned all that up. So that's all the little cleanup work that needed to be done. So there we are. We've got all the flat surfaces cleaned up. Now it's time to go in and clean up the final features in this part. So we're going to stop right there. Okay, so let's talk a little bit about final finishing passes and how they work. So we've got, all the surfaces mowed down to, on the flats, the large flats, to nominal. And now we've got to do a small flat end mill to get in between everything. And then we want to ramp in and walk around all these cavities and hit them to their nominal dimension, or 0, where everything's to size. So if we select the last two routines and we say simulate, and we let the simulation tool come up, and then we hit play. So it's going in and it's finding all the flats, and now it's finding all the ramp surfaces that need to get cleaned up, and it's taking them to 0. And so this routine called ramp is a 3D sculpting move that kind of walks around all the tall features and cavity features and just kind of works its way down in there. You can kind of see it coming in and cleaning up everything. So these are all roughed in here, and now you're going to see it kind of walking in and cleaning up all this, and making these surfaces nice and clean. You'll see it happen here shortly. Okay, here it goes. Okay, so it's kind of walking down the wall and cleaning up all this stuff and making it all smooth here. And we may want to hit it again as a final cut, but this gets everything off, and then we can put like a mirror finish on it. Um, and yeah, so that's what we've got. Okay. Okay, let's talk about the final finish on everything. And what we try to do is to really refine everything down so there's not so much polishing. So imagine like each step over on a ball end mill leaves a little hasp. And what we can do is we've gone into this ramp, and I've left, if I right click and I go edit, and I look at the amount of stock that I left. So I've left all these feeds and speeds at the default here for the material. And if I go to passes, you'll see the step down is 0.25 millimeters, and the stock to leave we left 0.01 millimeters. So there's a little bit left in here, and now we want to try to like really tune it down in there. And this routine is taking an hour and 42 minutes to run. So what I'm going to do is I'm going to click on the setup, and I'm going to create a new cut, and I'm going to use a parallel for the final one that goes to 0. And we've kind of gotten all the things that would snap off cutters down in there with that ramp taken care of. And I'm going to crank the spindle speed up, and I think that this one goes to 12,000 RPMs. So it's really, the speed is running really fast, and that'll leave a really nice finish. And then I want to go in and I want to go to passes, and I want to take, and the step over, we're going to go oh 02, something like that. And then we'll just run it right to 0. We don't leave any stock on here. And the cusp height, which is like how high it is at 0. So this is going to run right now, and I'm just going to go ahead and say okay. And it's using that same cutter, the little skinny one that's got the 2 millimeter ball end mill down there, and I'm going to hit okay. And this one is probably going to take 5-8 hours or something like that to run. And it's a very fine step that it creates, and we can pretty much pull the mold out and stick it in the molding machine and start making parts. So a lot of guys will sample a mold, and then they'll measure parts, and then they'll polish it after, hand polish it after they've sampled it. But a lot of these modern machines that run at these high RPM spindles can deliver some extraordinary finishes. And so you'll see this machine kind of walking up and down on things, and see if we can get to this simulation. So this is a final finish, and I don't know, I'm old school. I've just always done these parallels at the end. We could possibly use a ramp. The ramp I've always kind of thought is used for getting into small little areas to clear out the material, and then the parallel kind of gets that final finish there. So anyhow, it looks like it's crunching it over here. If you look at this little time thing here, when this gets all the way around, it looks like it's at 67%, and then it's coming around, and then we'll be able to simulate this, and you can see how refined it is. So it's at 82%, and once we simulate it, we should be able to pull the tool out of the mold, out of the CNC, and assemble it. And obviously we've got ejector pins to drill, and that's a separate subject. We'll pick that up in another lesson on drilling and reamers and center drills and all those tapping and all that stuff. So there's going to be a section after this on how to drill your water lines and your ejector pins. So I'm just going to click on this, and I'm going to right click, and I'm going to say simulate. And it looks like it's 52 hours. Way too long. Way too long. So that's 2 days of runtime. So we've set the step overs too tight, and so I'm just going to cancel it. I'm going to exit out of here, and I'm going to right click on this, and I'm going to change the step over, and I'm just going to go edit, and let's see here. We're going to go. Let's see. Where's my? We'll change this. Well, first of all, we'll keep the silhouette within this boundary. So we're going to select this boundary right here on the geometry. And we're going to selection. And then it'll keep it in there, and it won't have to machine outside of that. And then we're going to go over to the passes. And I set it way too tight. So I'm going to set this at like 0.5 millimeters. And or 0.05 millimeters. So that, well, actually, let's just say we'll say 0.1, and then the cusp height is only 0.003. So that's pretty good. I always think in thousands, so sometimes I have to do the math in my head. But I'm just going to hit OK, and let's just see what happens here with this. And we're going to go from 52 hours, and let's see if we can drive that down to like 5 or 10 hours on this finish pass. So a lot of times we have a gut instinct on what we think it's going to take, and then if we see a high number, we're like, oh, we over analyzed it, and we made the cuts too tight. So let's see what we've got here. All right, there we go. So now we're down to 8 hours. That's very acceptable. So this thing you could launch at the end of the day and come back in the morning, and it'll be done. The mold will be done. So that's kind of the goal, is to get it within like a 12-hour period. So we're going to simulate this, and let's see what happens. It looks like it's just machining on the vertical stocks, and it's going back and forth. I think if we show our leads, I think that's what will show you the path, or the cutter path. There we go. So it's moving back and forth in that zone, and just getting in and cleaning up the final details way down on the bottom of the cavity. So this is taking it to 0, and it knows that the flat surfaces are already machined, so it doesn't bother on them. And yeah, this is what we do. Okay.